All right, so my video quit, so I'll do the example in a separate video, but it'll be very short. So the example I wanted to do is scores on the 2010 AP exam. I suppose I could have looked up a newer one, but it doesn't matter. And so here's the list of scores and their probabilities, which is the probability distribution. Proportion is another word for probability. Basically, it's the decimal version, but it doesn't really matter whether you call it a probability or a proportion or a percent. They're all the same thing. 5, 4, 3, 2, 1. Nobody gets a 0. That's really weird to me that if you leave it blank, you get a 1. Yeah. So the first question is this a valid probability distribution? I got this information off the AP website, so you would think they would do it right? And that's a fancy way of saying, do they add up to 1 like they're supposed to? And also it includes, are they complete and disjoint? We're not leaving out any possible scores. We're not putting any overlapping scores in. That means they ought to add up to 1. If you add these up, it's kind of a little disappointing because the total, try it if you don't believe me, comes out to 0.99. That bothers me a little bit. The sum is 0.99, which is approximately 100%. What happened is probably these numbers got rounded off some, so they probably used to be longer and they got rounded off, and there's some round off errors in there. I'm going to say this is an approximately valid probability distribution. And I thought about fixing it so it wouldn't have that problem, but I didn't. So it's an approximate. It's got some round off errors in it. Probability distribution. And it's close enough for what we're about to do, except that the complement thing that I'm about to do might change depending on how you look at it, and I'll show you that when I get there. I could find probabilities off of this table, like I could ask you for the probability of passing the AP exam, which is officially the probability of getting a 3 or more score, which is these 3 put together. And you would just add them. That's the addition rule. So you can add 0.125 plus 0.224 plus 0.235, and that would give you that probability of passing. It's actually pretty good. 58.4% of people who took this exam in that particular year passed and got the college credit, and that's pretty good. And then if I want the probability of failing, that's the complement, or it's the probability of getting a 2 or less. There are 2 ways to calculate that, and because of the round-off errors, they come out different, and that's the part that's a little bit annoying. So you could do 1 minus 0.584, and you'd get 0.416, which is almost the same. Actually, it did come out the same. Why did that happen? I don't know. Maybe I'm wrong about it adding up to, hang on. Yeah, that's a 0 on the end, and then this comes out weird. Anyway, if you add these together, you get 0.41. Wait, I messed up somewhere, but that's okay. I should probably actually calculate it on my calculator and make sure, but it doesn't matter. The idea is 0.416 is the probability of 2 or less, and that's the people who did not get the credit. I was thinking if I added these together, I would not get that. And I'm going to do it again just because I'm curious. 3 plus 3 is 6. 8 plus 2 would be 406 if you just added these together. And that extra 1% came from the round off error. That is the extra 1% missing there. Okay, so I didn't mess up. I did it right. So I'm going to actually say you could do it the other way. 0.183 plus 0.223, which is 0.406. one of these is closer to right than the other. I'm going to say this one's approximate. All right, so that's an example of stuff they might make you do with probability distributions. And the homework for 5.2a is going to be mostly vocab and calculating probabilities with the addition rule or complement rule.